welcome back to Spring into Math 7. I'm Mrs. Campbell. Today we're going to be talking about one-step equations. Let's get started. Let's start by looking at solving equations using addition. When we write an algebraic equation, equality means that whatever we do to one side of the equation, we have to do to the other side. Here's an example. X equals 100 minus 22. So x plus 22 equals 100 minus 22 plus 22, or x plus 22 equals 100. So similarly, we can add numbers to each side of an equation to help solve for an unknown. So look at this example. It says solve x minus 3 equals 9. So we need to isolate our variable there, x, and we'll change the equation so that x appears by itself on one side of the equal sign. So right now our x has a 3 subtracted to it, and to reverse it, we could add 3, but we must do this to both sides. So x minus 3 equals 9. All we do now is x minus 3 plus 3, and then add 3 plus 9, and we get x equals 12, because the positive and negative 3 on the left side cancel each other out. And that helps us isolate our variable. Okay, solving equations using subtraction. When our variable appears with a number added to it, we follow the same process. Only this time, to isolate the variable, we subtract a number from both sides of the equation. So if we're looking to solve x plus 6 equals 26, to isolate the x, we need to subtract 6 from both sides. So x plus 6 equals 26, minus 6, we get x, because the 6's cancel out, x equals 20. Another example, solve x plus 20 equals negative 11. To isolate the x, we need to subtract 20 from both sides. X plus 20 equals 11. Subtract 20 from both sides, and we get x equals negative 31. Solve x plus 4 over 7 equals 9 over 5. So to isolate x, we need to subtract 4 over 7 from both sides. Here's our problem. X plus 4 over 7 equals 9 over 5. All we have to do is subtract 4 over 7 from both sides. So here we go with our problem of x equals 9 over 5 minus 4 over 7. But we're not done yet, because when we're subtracting fractions, we need to find the lowest common denominator. 5 and 7 are both prime, so we can just multiply those two, both of them, to find the LCD. So 5 times 7 equals 35. Here's our problem. X equals 9 over 5 minus 4 over 7. So what we do is multiply here 7 times 9 over 35 minus 4 times 5 over 35. We get 63 minus 20 over 35, simplified to 43 over 35. So make sure that you're comfortable with decimals and fractions, because to master algebra, you're going to need to work with them all the time. So be sure you've got that down. All right, looking at solving equations using multiplication. I want you to pretend that you are selling a pizza for $1.50 a slice, and you get 8 slices out of a single pizza. How much do you get for a single pizza? Now, you should figure out pretty quickly that 8 times $1.50 is going to give you $12. Now, you solve this problem by multiplying, whether you know it or not. The following examples do the same algebraically using the unknown variable x as the cost in dollars of the whole pizza. So 1 over 8 times x equals 1.5. So our x is being multiplied by 1/8. And we need to cancel this factor, so we multiply it by the reciprocal of 8. Again, don't forget to do this to both sides of the equation. So see here, all we've done is multiplied both sides by 8. Okay, and these 8's cancel out. So what we're looking at, once our variable's isolated, is x equals 12, because 8 times 1.5 is 12. Let's look at another example. Solve 9x over 5 equals 5. 9x over 5 is equivalent to 9 over 5 times x. So x is being multiplied by 9/5. So to cancel, we multiply by the reciprocal, 5 over 9. There it is, multiplied. And once we do the math there, these cancel. we get x equals 25 over 9. All right, now solving an equation using division is another way to cancel any terms that are being multiplied by x. So suppose you buy 5 identical candy bars and you're charged $3.25. How much did each candy bar cost? Now, you might just divide $3.25 by 5. That would work. Or you may convert to cents and divide 325 by 5. But let's see how this problem would look algebraically. Solve 5x equals 3.25. And here, to cancel, we're going to divide both sides by 5. So we did that here. The 5's cancel out, and we get x equals 0.65. Another example, solve 7x equals 5 over 11. All you do here is you multiply both sides by 7. I even skipped the step here that would cancel out the 7's, and we get that x isolated. And now it equals, x equals 5 over 7 times 11, which is 5/77. Let's look at some real-world problems using equations. Okay, in the year 2017, highlight the information here, Anne will be 45 years old. In what year was Anne born? Okay, the unknown here is the year Anne was born. This is going to be our x. Okay, so here's our equation. X plus 45 equals 2017 or 2017. All we need to do to isolate the variable is subtract 45 from both sides. And we get x equals 1972. That was pretty easy. Anne was born in 1972. All right, another example. In good weather, tomato seeds can grow into plants and bear ripe fruit in as little as 19 weeks. Laura planted her seeds 11 weeks ago. How long must she wait before her tomatoes are ready to eat? All right, well, we know that the total time to bear fruit is 19 weeks and that the time so far is 11 weeks. This one's actually pretty easy if you think about it. So our unknown is the time in weeks remaining, so we call that our x. That's the unknown. Here's our equation. X plus 11 equals 19. Subtract 11 from both sides and we get x equals 8. Again, simple operations. All right, this is our last example. In 2004, Takeru Kobayashi, I hope I said that correctly, of Nagano, Japan, ate 53 and a half hot dogs, he's a big eater, in 12 minutes. He broke his previous world record set in 2002 by 3 hot dogs. 3 parts of this question. How many minutes did it take him to eat 1 hot dog? How many hot dogs did he eat per minute? And we need to calculate what his old record was. So let's look at the A question. How many minutes it took him for him to eat 1 hot dog? So we know that the total time for 53 and a half hot dogs is 12 minutes. So if the time in minutes for each hot dog, or the unknown, is x, that's our variable, then we can write the following equation. 53.5x equals 12. Okay, all we need to do here is divide both sides by 53.5. We get x equals 12 over 53.5, which comes out to 0.224. And then minutes convert to seconds, multiplying by 60. So this time taken to eat 1 hot dog is 0.224 minutes, or about 13.5 seconds. Pretty quick. All right, part B, how many hot dogs did he eat per minute? Let's look what we do know. We know that he ate for 12 minutes. His rate per minute is our new unknown. Okay, so to avoid confusion with x, we'll call this y. And we know that the total number of hot dogs is 53.5, so we can write the following equation. 12y equals 53.5. Okay, all we need to do is divide both sides by 12, and we get y equals 4.458. So he ate approximately 4.5 hot dogs per minute. That's pretty amazing. And finally, C, what was his old record? Well, we know his new record is 53.5. And also that his new record is 3 more than his old record. So it's actually pretty easy to write out. We have a new unknown. We'll call his old record x with the following equation. X plus 3 equals 53.5. Subtract 3 from both sides, we get x equals 50.5. So his old record was 50 and a half hot dogs in 12 minutes. All right, everyone, that does it for this lesson. Thanks for joining us. We'll see you next time. Bye-bye.